This is a vacuum pump that I recently got at an estate sale for about $20, and it's a really nice unit. And what caught my eye was that it's made by Blue Point, which is a Snap-on brand, just like my own meter, my multimeter Blue Point. And I know they make high quality products, and I just couldn't pass it up. And what people use these things for, among other things, and it's the same reason I bought it, is they use it to evacuate air conditioning systems on cars. And I've always wanted to get the air conditioning working on my 1972 Lincoln, and I've always been looking out for a vacuum pump, and they've been too expensive. And so I picked this one up thinking, well, gee, I've struck gold. I've now got a vacuum pump which completes everything that I need to go ahead and evacuate and recharge that system. But it's got a problem, and which is kind of disappointing. When I got it home, before I plugged it in, I noticed that it has this flexible coupling on here, and I took my hand and tried to spin it around, and I couldn't spin it around. And if I put a pair of pliers on the metal part here and try to turn the motor end, you can see that motor torques over, but that shaft is completely seized. So my heart just kind of sank because, you know, I hope it's not the pump that seized that. The pump is why I got it. I can buy a new motor. That's not a big deal. You can buy these all day long from Granger. But these pumps, that's going to be an OEM specific type of pump. If I come over here on this side, and I don't know how well the camera will pick this up, you can see that shaft on the vacuum pump actually turn as it actually twists the flexible coupling there. So I think this pump is actually good. It's a nice pump, kind of looks like my air compressor pump, or air compressor almost. It's got a oil reservoir in here, and you can see it's low on oil but still has oil. And the thing actually came new in the box. Even though it says Blue Point, it's actually a Marvac model, Marvac Scientific Corporation, GA-271A model number. I haven't really heard of Marvac, but it seems like a very high quality unit. And it also came with the oil, which looks equally just as old, probably from the 70s. I'm not even sure if this oil is good anymore, but this is the kind of oil that you fill up inside the vacuum pump to keep that lubricated. And true to its good design, it's got a pretty hardy motor in here. I believe this is a standard split phase AC induction motor. But you can always tell by looking in the back here, and you can kind of see a little wheel back in there that will operate on inertia. As the motor spins up, it gets faster and faster. It'll cut out the starting winding and run on the run windings. And it's also got places you can lubricate the front and rear bearings as well too, which I fear, just like in cars, nobody ever bothered to lubricate it. So there's two scenarios that might have happened here. A, the motor was run dry. That'll be the worst scenario, is that it was run dry and basically destroyed itself. But what I'm thinking is I might get a little bit lucky here, is that it sat in that guy's garage for so long, it basically just seized up due to condensation getting inside. Whereas I can, if that's the case, I can just pop off these end caps and polish the front and rear shafts on the armature and re-lubricate it and press it back into service. I hope I can do that, but worst comes to worst, I'll have to buy a new motor, but I'm thinking I might be able to go ahead and save it. And before I get started, I want to see if the motor is actually worth saving, which is why I've got the multimeter out here. I want to see what kind of condition the windings are in. I want to just see if there's any kind of resistance here at all. So I've got the meter set on ohms or continuity, and I just have them attached to the plug that goes into the wall, and we'll go ahead and turn it on, and we'll see if we get a change in reading. Yeah, good. That's about right. Turn it back off. So I know that the windings aren't opened up or burned up. This motor electrically is good. I'm going to see if I can go ahead and work it loose. I've got a couple of different ways I can try to do that. I got some vice grips of various sizes. What I don't want to do is scar up the sleeves on this flexible coupling too much. So if I can't apply enough torque with the vice grips, I'll have to go ahead and take the motor apart and see what these shafts look like inside. So let me try to do that, and I'll be right back. Well, I got the handle taken off and put back there so I can get a direct 90-degree or perpendicular, have the pliers on perpendicular to the coupling. And I've got all my pressure going to the very end of the coupling to avoid bending it in toward the flexible part. And it took both hands, and it's still very tight, but it will move. I think this thing can be saved. You can see how that motor wants to torque over. It's still got a lot of resistance, but I might be able to work that out. I'm going to try to see if I can, I haven't popped off these lubrication plugs yet. I might try to see if I could just force some oil in there and just work it back and forth. It might take an hour or more just to kind of let that oil penetrate in there. There's probably a wick inside of here. It's probably not a needle bearing or a ball bearing. It's probably just a bushing, maybe a sintered bronze bushing. And see if I can get that lubricant to do its job. It's a nice motor. It's made by Emerson out in St. Louis, and a lot of the data plates actually damaged, unfortunately. It looks like a 3rd horsepower motor, 1725 RPM, but it's nice enough to tell you how to maintain it. And I don't have any SAE 20 oil, but I do have some nice synthetic 30 weight oil that I use in the lawnmower sometimes. I think that's going to be close enough. The synthetic oil should flow equivalent to maybe a 20 weight oil. So let me see how far I can get with this and avoid taking the whole motor apart, which I can do, no big deal, and see if I can actually get this thing plugged in and running. Probably by the looks of it, and the container and everything, probably hasn't run in 20 or 30 years. We're now looking in one of the oil fill caps for the front of the motor, and I hope you guys can see clearly there's a wick down in there that looks completely dry. And we'll go toward the back here and zoom in. And I think you guys can see in there as well too, there's a wick back there. So I'm going to go ahead and try to lubricate that thing and see what I get. It doesn't look like this motor was ever maintained, and that's really a shame. That's why I'm so big on proper maintenance and lubrication, like with the car videos I do, because you can really save yourself a lot of money just by keeping things lubricated. And so let me see if I can get this whole thing running. Well, getting deeper into it, there are signs of life. I went ahead and removed the vacuum pump assembly and also the coupling to further verify that the motor is actually the one that's seized up versus the vacuum pump. And I was right. The vacuum pump turns freely, which is really good because that's not something I could find. But the motor is still pretty much seized. But there are signs of life. I added copious amounts of 30 weight motor oil to both ends of the shafts to lubricate the oil wick. And I also used the heat gun to focus heat on the end caps to expand the bearing away from the armature shaft and also let that oil further penetrate down in. And it does run. But it's definitely labored. And if I run it for too long, it's basically just going to run hot and probably damage the bearings even more. But I now have more confidence. I can go ahead and put a little more time into it. And you can see how long that quickly that thing slowed down, and I cannot turn that shaft very easily. I have to basically get pliers to turn it. So I am making progress. I think I might be able to save this, but I do want this to get just a little bit better. And getting the motor out is going to be easy. I've already gotten the front part of it taken off, and it'll just lift right off the frame. I still have to take the rear connector off, and then I got to pull these 4 through bolts out of here, and then pop the end caps off, and I'll get a much better idea of what that armature looks like, and also the bushings. Well, I've got the motor apart, and didn't come without some blood here. That's actually oil that I put in there that I purposely let drain back off. You can see how contaminated it is, so I kind of used the fresh oil to wash out all the contaminants that were in the wicking here, which you can kind of see on the edge of that bushing in there. And there's the output of the wick. And I gotta say, I'm impressed with this motor. It's a very well made motor from Emerson out in St. Louis, Missouri. This is a standard split phase AC induction motor, so what we have here is the stator portion, which is where all your windings are, and they look to be in very good shape. This is actually the stator right there, and then here's the back of the motor. And how these things work, it's really neat. Most, if not all, residential homes, we only have single-phase power. And because they're single-phase power, there's no way to set up a rotating magnetic field, which is what you need to spin this armature around. And there's a couple of different ways you can do that. You can have a capacitor shift the phase of the AC voltage to give it a jump start. A good analogy I can use is if you have any old fans from the 1920s or 30s, they don't do anything but sit there and do this, and you got to kind of use your finger to give them a tug, and once you do, they'll start spinning. This motor works on the exact same principle. What you've got in here are 2 sets of windings. You've got fairly heavy gauge windings right here, and then you have more fine gauge windings there. And these windings are wound around the stator offset by a certain number of degrees. And the fine windings are the run windings, and they're continuous duty windings, so they're a little bit lighter gauge. And the thicker windings in here is the starting winding. And the starting winding is what's taking place of your finger in the old 1920s fan to start this armature turning. And so what happens is when the motor is at rest, you've got these contacts back here that are normally closed. And then on the back of the armature, you've got this wheel back here with calibrated spring tension that as the armature spins up, just due to inertia, slides forward. And so when the motor's at rest, the starting windings are engaged, the big heavy thick windings, just like you see here. And then when the that little wheel goes in further, it pushes on that, disengages the starting winding, and then these contacts, when they close, they engage the run winding. And that's how the motor starts up and continues to run. And these motors are found in washing machines, dishwashers, dryers to rotate the tub, air compressors, all kinds of things. It's a good motor, except that it doesn't have the starting torque you would need for a large air compressor. For the higher torque values, you'd need a capacitor run, capacitor start motor. But getting back to the subject at hand, I just think that's kind of neat. The shaft on this armature looks to be in very good shape. This is the rear of the motor, and then over here, here's the front. It's a little bit polished, but still very smooth, no nicks or burrs. And here we have the front end cap, and you can see the bushing in there, how they kind of designed that. It looks like it's built in, it's just part of the aluminum front cover, but they put a couple of hashes in there on the left and right side to kind of act as channels for the oil to pass through from the tip of that wick. And unfortunately, this thing still fits on here kind of tight. I'm going to see if I can continue to work with that. The idea is that the shaft is supposed to ride on a continuous film of oil, kind of like my finger is right here. It's never really supposed to touch the bushing at all. And that's sort of the idea, but it's not doing that for some reason. The shaft was still dry when I took it out. So I'm just, I think it just might be a matter of soaking this wick more with oil and making sure it's completely saturated and just kind of working with it. But from what I can tell, this motor did not have a lot of power on hours, judging by the coloring of the wiring and everything and the condition of the insulation on the wiring. It doesn't look like this pump was used very much at all. And the contacts back there for the cut out of the starting winding and cut in of the run winding are not burned very much, so I don't think this thing had a lot of cycles, start-stop cycles. And the rear bushing looks very much the same. As you can see, they do look in very good shape. They're kind of polished, but very, very smooth. So I think it's just a matter of continuing to work with it and seeing what I ultimately end up with. I figured this would be a good time to show you guys. I got the end cap put on here because I was working with the rear bearing, and this really demonstrates pretty well how the starting mechanism works just by inertia. As you can see, the contact here is normally closed, and it's got this piece here that's rubbing against this black piece, and as the motor spins up, inertia forces the black piece out, and you can kind of see how that contact opens to cut out that starting winding right there. So I just wanted to show you guys a lot better how that worked. But anyway, looks like the armature might be a little bit crooked. That might be my problem, but I'm going to go ahead and continue working with the bearings and see what I end up with. Well, I've worked with it and worked with it and worked with it, got it all put back together and ran it for a while, so it's pretty warm. And it's a little bit better, but as you can see, that shaft should not have enough friction to hold up these vice grips. So those bearings are still really tight, and you saw what they looked like. The armature shaft is still really smooth, and the bearings look smooth, so I'm not really sure what's going on. There's no real reason why they should be that tight. There's no corrosion or sludge buildup or anything like that. There's a chance that as I continue to use the motor and the bearings wear slightly, they might wear just enough to where the tolerances will be reasonable, so where we would have a lot less resistance on that shaft. But that's about as good as I can get it. I'm going to go ahead. The motor kind of labors just running free like this. It does run kind of hot, so I'm a little suspicious if it'll actually be good enough to run the vacuum pump. But I'm going to try to put the vacuum pump back on as well as the flexible coupling and see how well that pump runs, as well as see how fast the motor is able to turn that. The motor might be working so hard to overcome the friction in the bearings that it might not have enough ass to turn the pump over, because the pump is a little bit freer to turn than the motor is, but it does have some resistance because it's doing work, you know, drawing a vacuum. So we'll see how far I can get with that. Well, I'm not completely happy with how it turned out, but I do have it all put back together like it was. And I've filled it up with a little bit more of the oil. I don't have any idea what I'm doing actually with this model pump because I don't have any literature on it, but I'm assuming it would be between these two holes. So I think it's got at least sufficient oil in there to avoid any damage. And I went ahead and used this old oil here, and whoever had this pump cared for it a lot because they put this plastic under the cap and then screwed it down. So that oil, even though it's old, looked like it was in pretty good shape. So let's go ahead and see if this thing has enough power to run the pump. I'm going to go ahead and plug it in directly there instead of using the switch because I want to prevent any wear and tear on the switch just because I've been testing so much. And that's what it sounds like. It's drawing in air here, or sucking in air here and blowing it out here. And that motor is heating up pretty quick actually, but it's got pretty good suction. Doesn't have to be a whole lot just to evacuate an AC system. This thing probably hasn't run in 30 years. So it's definitely a lot more free than it was before. I can turn it over by hand, but there's just still more resistance in there than I'm really comfortable with. But now I at least know that the vacuum pump itself works. If worse comes to worse, the motor will eventually burn up and I'll just get a new motor of the same frame and everything from a motor supply company like a Dayton motor or a General Electric motor or something like that from Granger's. But I think I've brought this thing back to life as much as I could. I'll know in the future. I'll keep playing with it. I'll probably end up taking the pump back off of here and just running the motor without a load on there just to see if I can work those bearings loose. But overall I think I've done about as much with it as I possibly could to get it back to life. I'm not sure if anybody has any information on this that's watching this video. I'd love to have some. There's the model number. It's if the camera decides to focus this century. It's made by Marvac, M-A-R-V-A-C. It's model GA-271A. And I filled it up basically by taking off the breather. I'm not sure how you're supposed to fill it. I just took that breather off and filled it up to where you see in the sight glass. And this ends up being a drain actually. I actually overfilled it and had to drain a little bit of it out. And then I think it draws air in here and spits it out here. This thing unscrews. I'm not exactly sure what that is. But overall, not a bad project for 20 bucks, and hopefully it'll help me evacuate the AC system in the 72 Lincoln.